Thank you very much for your introduction. The story of managing common add-ons with more than 1,000 Kubernetes. With this title, let me talk about this. So let me introduce first of all. I'm a software engineer at G-Lab Corporation. My name is Shinya Uemura, and I belong to customer success team. So at Twitter and GitHub, I use an account name Ueshim. And outside of work, I am involved in the management of several communities such as Kubernetes Meetup Tokyo and the Kubernetes Change is a sharing group. So the G-Lab Corporation that I work for is a wholly owned subsidiary of Yahoo Japan Corporation and was established in 2015. And do research and development of infrastructure technologies. I managed Kubernetes as a service PaaS for Yahoo Japan Corporation. So this is today's agenda. First, let me talk about the features and roles of Yahoo Japan's private Kubernetes as a service. Then I will talk about the management of common add-ons, and finally about monitoring of add-on. So first, I would like to talk about the Yahoo Japan's private Kubernetes as a service. At Japan, we provide Kubernetes as a service in-house. So on-premise cluster, there is a service as clusters generation as well as management as well. And that is provided as G-Lab. And this is developed by G-Lab, and it is operated by Yahoo Japan. At the launch of service in 2017, that has started from 5 clusters, but in 2018, so more than 1,000 of clusters are running on it. And in the case of the number of VMs, it's more than 41,000. And in the case of number of containers, it's 745,522. So it is one of the largest number of nodes. And here shows the image of the use of CaaS, Kubernetes as a service. So the users will give a request to create clusters, and on the in-house stack, Kubernetes is created. And cluster is not a multi-tenant, but issued as a single tenant. Therefore, the users can occupy the services. So as a characteristic of Yahoo Japan's private CaaS, the default secured settings are available. Even if the container is hijacked, the privileges can be the containers that have the strong privileges cannot be created, and also the DNS domain that can be available at ingress would be allocated for each cluster. So utilizing ingress, the applications utilizing ingress can be run without any cumbersome applications. As for the Kubernetes operation, it is very complicated. Therefore, we provide as managed services, and through these services we reduce load on the side of the customers, such as restoration of the node as well as the safety upgrade with zero downtime, and coordinate with monitoring services, and also the automatic data store backup. And also it is scalable. So based on within the quota of the request from the developers, but this can be changed based on one command. In CaaS, there are more than 40,000 servers required on VM. From the unit, you can guess that for these management, automation is mandatory. So in CaaS, this would be done by Kubernetes controller in CaaS, and through this, clusters and VMs management are automated. And through this through this Kubernetes controller, declarative settings would be used for the cluster management. And in the context of Kubernetes, the word controller is to monitor the state of the cluster and also make changes and requests upon necessities and execute the control. So as for the details, if you would like to check the details, please check this URL on this slide. And on the right on this slide, this actual Kubernetes cluster custom resources representation. Through controller, there is a declarative management available. So if you upgrade cluster, then you can just change version field and CaaS controller can be upgraded. And similarly, so node scale in, scale out, scale up, scale down, and those images can be also automatically done by controller. Therefore, depending on what the users would like to do, without any knowledge, those operations could be executable. So the actual users would use the operations through CLI provided by CaaS. And there are other functions and features available, but this is out of the scope of my presentation, so I'm sorry this is in Japanese. However, there is a slide for reference. So if you have an interest, please refer to this slide. So up to now, I covered the Kubernetes cluster management by users. So it was a brief explanation. Then, so in order to provide, by providing users Kubernetes by CaaS is not enough. So some of the functions of the Kubernetes functions can be independent on the external Kubernetes components. So the name of the name resolution within the Kubernetes, as well as A7 communication receive at Ingress, as well as HP scale, those are separate from the pure component, cluster component, Kubernetes component. So these components, rather than managed by each of the users, but on the side of the CaaS, this should be managed, and that will reduce the overall cost as a company. And also, in addition to this is not mandatory, but in many of the clusters, there are common usages, as well as, although this might be not required for users, but from the point of the security and operation, on the side of the CaaS, there are some applications that require some running. And as for these, so the common applications to be used, they are managed by CaaS, so that users, clusters is used for the operation. And we call them add-ons. So as the examples of add-ons, this would include Ingress controllers, as well as DNS operation, core DNS, as well as Prometheus for monitoring.
The first reason why we provide add-ons for CaaS is to improve user convenience. By managing commonly used applications on the CaaS side, users can focus on developing applications. As mentioned in the beginning of the presentation, users can focus on developing applications. As mentioned at the beginning of this presentation, users cannot create containers with strong privileges on the cluster. However, there are actually applications that require strong privileges but are useful for many users. Some of these applications are available as add-ons to enable them to be used without giving the cluster users strong privileges. The second reason is security. The company's security policy must be applied to all containers created by users. Therefore, we provide add-ons to enforce the policy. The third is monitoring. We provide add-ons for monitoring, for CaaS to monitor the users' clusters, and also for the users to monitor the applications running on the cluster. there are two types of add-ons, those that are mandatorily enabled and those that can be enabled at the user's discretion. Forced add-ons include cluster monitoring and security-related add-ons, as well as components that are external to Kubernetes, such as ingress controller and core DNS. Add-ons that can be enabled at the user's discretions may increase the user's development and operational efficiencies or may be useful, although they are not required for all clusters. For example, we provide a node local DNS cache as a DNS cache mechanism for applications with name resolution heavy characteristics, or Thanos, the Prometheus remote storage for users who want to persist metrics. Add-ons run on the user's Kubernetes just like the user's applications. But they run on an add-on specifics namespace, and the user cannot directly modify the add-ons in any way other than that provided by the CaaS side. Add-ons should not only be deployed to each cluster, but also updated as necessary. For example, to add new functions, fix bugs, or address vulnerabilities. Add-ons must also be added and removed. For example, applications with strong user demand should be added, and add-ons that are impossible to maintain or are no longer used should be removed. Some add-ons require different support for different Kubernetes versions and must only be deployed on the corresponding Kubernetes version. We have to do this kind of maintenance on all our huge clusters. So I will talk about maintenance of add-ons. So in CaaS, when maintaining the add-ons in CaaS, so here are the main requirements. The manager and the users can selectively enable or displace add-ons, and also add-on setting needs to be able to be changed. And if there are so many clusters, so we need to reduce the operating cost. And automating add-on updates, and we need to be able to respond to add-on errors and add and delete add-ons. And there are other requirements, but these needs to be satisfied. In fact, there's an officially developed Kubernetes controller for add-on management called Add-on Manager. It is a controller that keeps applying a predefined add-on manifest and is, roughly speaking, a shell script that loops through kubecontrol apply -prune command. It's a shell script. It applies all manifests in a particular directory, deploys add-ons if they do not exist, and modifies them to match the manifest in the definition if they have changed. If the add-on manifest is deleted from the directory, the add-on is removed. It does not manage add-ons for multiple clusters, but runs on each cluster and manages the add-ons for that cluster. The official add-on manager is a simple implementation and by itself could not take into account environmental differences in our CaaS or deploy add-ons that meet our requirements. For example, the size, so what we couldn't do, for example, is the size and number of nodes in each cluster varies. The more nodes there are, the more monitoring tasks are required, and the more resources are consumed by the add-ons monitoring the nodes.
Some add-ons consume more resources depending on how they are used. In this example, for example, for a metrics monitoring add-on, the more metrics an application outputs, the more resources it consumes. And for an add-on that records cluster events, the more cluster operate it performs, the more resources it consumes. And this means that even with the same add-ons, the requested values for CPU, memory, etc. will be different for each cluster. Also, some add-ons are only required by some users. Deploying such add-ons on clusters will also consume unnecessary resources, and if they have side effects, they cannot be deployed on all clusters. Therefore, the add-ons you wish to deploy may differ depending on your usage. And there are also some that require different values to be embedded in the add-on manifesto for each cluster. For example, add-ons that publishes web UI by Ingress have different DNS domestic available to Ingress distributed to each cluster. Therefore, the appropriate domain must be set in the manifesto for each cluster. Other administrative information, which varies from cluster to cluster, is required as parameters for the add-ons operation. Similarly, the values varies from cluster to cluster, so the value must be changed depending on its cluster. Therefore, we needed a mechanism that would allow users to freely change some of the settings depending on their usage and to automatically embed appropriate values for the cluster to the manifest. To meet these challenges and requirements, we have developed ZCP Add-on Manager, that is called ZAM for short. In the later presentation, we often call the name ZAM, so I hope you could be familiar with this term. ZAM also works on each cluster as does the official add-on manager. The main mechanism is the same as the official one, but several unique features are implemented. The first difference is that ZAM is implemented as a Kubernetes controller in the Go language. The Go language was selected simply because Go's library have the most generous official support in Kubernetes. The second difference is the addition of the ability to enable and disable add-ons. The function allows users and administrators to enable and disable add-ons at their discretion, and cluster users can freely enable and disable add-ons within the permitted range. The third difference is that add-on manifests can now be managed as templates. This allows different values to be automatically retrieved and embedded for each cluster and allows users to safely customize parts of the add-ons manifest. From this, I would like to talk about how to release and deploy ZAM. ZAM is released with a set of add-on manifests. And these are released together as a single container image. Therefore, ZAM release does not necessarily include only updates to the ZAM. But even if only add-ons are updated, they are still subject to the release. In this example of the slide, it's an example of a Prometheus update being released as ZAM version 1.241. This is done to treat these resources immutably and to simplify updating. ZAM has a corresponding release branch for each minor version of Kubernetes. Kubernetes may make changes to the API with each minor version, and some add-ons and XAMPs depend on the Kubernetes API, so it is necessary to change what is released with each version. The main branch is used to manage XAMPP to the next minor version of the Kubernetes to be released. Depending on the changes, cherry-pick to the respective release branches. As long as Kubernetes continues to use the same minor version, updating the patch version is essentially not a destructive change. Therefore, the same policies apply to XAMPP, and we try to avoid including destructive changes as much as avoid including destructive changes as much as possible when using minor versions of the same XAMPP so that the users can use the cluster with peace of mind. Incidentally, so we can change that we call changes that significantly change the field of the operation, eliminate add-ons, or require some action on the part of the cluster users. Those are disruptive changes. Because of these releases, XAMPP must be deployed with a version of XAMPP that matches the minor version of Kubernetes that is running. However, Kubernetes upgrades can be performed at any time at the user's discretion. Therefore, the XAMPP needs to be released in conjunction with that work, but it is not practical to release the XAMPP while coordinating them, because we manage about 1,200 clusters, so each of them, the management in coordination would not be possible. There are some other patterns that must be considered in deployment. For example, you may want to update only one minor version of XAMPP in the entire cluster, or you may want to apply the latest version of XAMPP to a specific cluster for testing. Or you may want to support updating XAMPP in some clusters. So that is why we developed XAMPP Updater, a Kubernetes controller specifically for deploying XAMPP. This also runs on each cluster as run XAMPP. It detects the version of the cluster it is running on and deploys the appropriate version of XAMPP to that cluster. XAMPP runs a different one for each minor version of Kubernetes, but XAMPP Updater runs the same one on all clusters provided by CaaS. So the same version can run. This allows the appropriate XAMPP to be automatically deployed to each cluster, even if the cluster is upgraded at any given time.
So this might be a little bit detailed, but the XAMPP Updater is controlled by two configurations. One is a channel called version list. So the XAMPP version, which is described on the channel, and the version list configs are shown in the bottom left-hand corner of the slide. The channels are marked with stable or RC. These we call channels. The key of the object in the channel is the minor version of Kubernetes and the version of XAMPP in which the value is deployed. For example, if you use the stable channel, XAMPP Kubernetes version 1.24.2 will be released when you use Kubernetes version 1.24. If you use the RC channel, XAMPP version 1.243 RC1 will be released. The other is a config for controlling the behavior of the XAMPP updater called XAMPP updater config, as shown in the diagram at the bottom right. These settings can be used to control which channels are used or to enable or disable the XAMPP updater's XAMPP update function. In more detail, these are distributed on the cluster as config maps, and XAMPP updater is constantly watching for changes in these config maps. I will now explain how to use these configurations in more detail with the help of diagrams. Version list is constantly watched for changes by XAMPP updater. As shown in the slide, if you change the version of XAMPP released for Kubernetes version 1.24 from version 1.24.1 to version 1.24.2 in the version list, XAMPP updater will upgrade the XAMPP on the cluster to version 1.24.2. This makes it possible to upgrade the XAMPP of the target cluster only by simply distributing the same version list to all clusters. So in this case, XAMPP for Kubernetes 1.24 only will be upgraded in this case. The XAMPP updater introduces the concept of channels. A channel is, as I explained earlier, is defined in the version list. The channel defines the version of XAMPP that should be deployed in each minor version of Kubernetes. XAMPP updater refers to the stable channel by default, but channels defined separately are also available via a configuration file. So, by using the RC channel on some clusters as shown in the slide, it is possible to use the RC XAMPP on those clusters. So, how do you distribute the XAMPP updater and config files? There is a controller called default manifest deployer that is dedicated to distribution to all clusters. This distributes a common manifest to all clusters discovered by CaaS. This distributes the version list and XAMPP updater mentioned earlier. The XAMPP updater config, which is used to configure the channels used by XAMPP updater, has a default behavior defined. So if there are clusters that need to be handled individually, this can be controlled by distributing it only to those clusters using a different mechanism. Lastly, I will explain about monitoring of add-on systems. Add-ons, XAMPP, and XAMPP updaters run in their own clusters. They are not centrally managed, and each works independently. However, as a CaaS developer or operators, you need to make sure that they are working properly. Each user cluster is running Prometheus as an add-on. It collects add-on, XAMPP, and XAMPP updater metrics, and this is where the conditions for alerts using the metrics are defined. Some of these alerts and metrics are collected by Prometheus managed on the CaaS side using the federation functionality of Prometheus. This enables anomalies in add-ons and clusters to be detected on the CaaS side. It also provides visibility into whether the intended add-ons are being applied to users' clusters, which add-ons are deployed on how many clusters, which XAMPP versions are being applied, so on and so forth. Here is the summary. Yahoo Japan Corporation and ZLab Corporation developed and operate a private CaaS. The private CaaS maintains not only Kubernetes clusters, but also common add-ons running on all clusters. Management of add-ons is automated by the Kubernetes controller, and XAMPP deploys and updates add-ons. XAMPP updater deploys and updates the appropriate XAMPP for the cluster in which it is running. Default manifest deployer, which deploys and updates the XAMPP updater to the respective cluster. Each add-on system runs independently and is monitoring to ensure that it's working properly. With these, we are able to manage add-ons for approximately 1,200 clusters. That was all from me. Thank you very much.
Thank you very much, Uemura-san. Thank Mr. Uemura. So, as plus talk, based on the points that the audience is interested in, we would like to go into the depth of such topics. And we will take questions from the audience. So if you have a question, press the question mark to pose your questions. We welcome your question. Manji Wataru is the questionnaire for this session from Line Corporation. So please introduce yourself briefly. From Line Corporation, there is a private club called Delta, and I am working for this team. I'm Wataru Manji. So what kind of topics were you interested in? Should I say ZAM or add-on manager? So anyway, ZAM, it can incorporate all the renewals to one version of storage, but one add-on would like to use stable one, and another want to use something different. Do you have such kind of conflicts? Well, such kind of granularity has not existed. So as was mentioned, it was a kind of rough level of management. So in the unit of package, if and when they're separated, and that kind of granularity of the management cannot be done. So you just make a development and the operation for the Yahoo Corporation. So in order to separate between these, is that the intention of that way? May I ask you once again? Excuse me, so I should add some words. For example, so without separating those, so add on a version 1, so what version 1 and add-on B can use version 2. So maybe you can set up API so that users can select which one that they want to use. So add-on, so if lab Z needs to run various servers, and based on the unit of tag or some others, maybe you can package it and you can make a package with some add-ons group. Then you don't have to do anything about the management. And also the disclose tab, or just select from the disclose tabs or container versions, and there will be a separation from the operation. So is that because you want it, or is this a natural flow?
So the management method that we have right now. So the intent of my question is so packaging fully in the container, and the users can use it. The Z-Labs really confines that into the container, and that's it. And Yahoo Japan cluster users will take what is confined, and instead the flexibility is a little bit sacrificed. So for Z-Lab to guarantee flexibility to reduce the operation cost, did you do it on purpose? Yes, we did it on purpose. I see. Because the users, we wanted to really make it agnostic for the users on which versions they use. And if some action is used on the user side, we will notify them. So by limiting the choice, we made it give them freedom instead. So I think that is a good decision. You made this clear decision. Maybe I missed it in your presentation. The Prometheus for each cluster, is that managed as part of the add-on? Yes, that is managed as part of the add-on. And the setting or the config of the Prometheus, the scrape config from here to here, Z-Lab wants to use to manage clusters, and what the users can use is confined in the variables. The Prometheus actually has a very limited area of where you put it into the config. There's config is too flexible, so by making this narrow, so we made the scrape config fixed. So we have fixed it to quite a large extent. So what the users can configure is very small as far as Prometheus is concerned. And so by having a special annotation on the pod, you can get that port number. Yes, that is right.
So by adding annotation to there, so you can expand the scope. Yeah, that is convenient. Thank you very much. So the data stored in Prometheus, they transferred to somewhere else. So I have an interest in this area because I'm SRD. Right now it is not transferred. So there is an add-on to enable it. In the description there are sums. So if you enable sums, then that will be automatically transferred to add-on, and the object that will be also sent to the object storage that user defined. So that means users can manage the data by themselves in discretion. However, in basically ephemeral is you basically use. Therefore, once it is deleted, it is done. It's gone. Okay, so that's for one cluster. So Sanos for total Yahoo Japan. So if agents are trying to join, so that will not be combined to sums and so on. That's not the case. And also besides that, with Prometheus and also in-house monitoring system, there is YAMAS service. So to those service providers, we can transfer metrics. That's also possible, and that can be selectionable from the point of the users. I see. That's interesting.
So confining everything to the cluster, you did that intentionally. So if you make it something as a service, that seems to be a lot of burden. So really to separate out into small teams, that happens quite a lot in add-on related teams. So this type of add-on we want to build. So if you plan on new add-ons, do you listen to users' voices, and also do you look into the situation where the add-ons are not yet applied? Yes. In the ZCP so the communities were held periodically, and we did surveys at the communities, and as support, we listen to the users' inquiries. We look into the users' inquiries, and if we see any add-ons which we see as necessary, we add them as long as we can manage them. I see.
That's good. So, as there are more add-ons, so the providers our side should have more knowledge. So, as within this scope, this is okay. But as for the management of add-on management, the scale of the resources is not enough. So once you provide as add-ons, the security of the add-ons as well as version verification will be the ones that you take whole responsibility. Right? That's the most difficult ones. So we try to simplify the add-on side as much as possible. I see.
So Line private cloud has a client as a service, and plugins and add-in type of thinking is a little bit different. For example, there's an add-on called Log Center. In the Kubernetes cluster, the special pod log, if you designate that, Elasticsearch clusters, and you can send the add-on to a certain Kafka topic. And those are add-on to connect to the external world. But listening to you, the add-ons offered by Z-Labs, there's only a few of those. So what we offer as add-on are really confined to our internal system. But of course, linkage with outside world, that type of connection is needed in many parts. This is an area which Z-Lab cannot work on because this involves Yahoo Japan Corporation operation side. So Yahoo Japan side operator offer that as a different add-on. So it's a non-them. Yes, there are add-ons which are managers provided by Yahoo Japan side. So add-ons which has connectivity with Yahoo Japan side are made by Yahoo Japan side. So there's this division of labor here.
So in order to keep logs on a specific space, then that is provided by Yahoo Japan. Yeah, that's an add-on by Yahoo to collect such logs. That's also available from Yahoo Japan. So I think there is a clear separation in this area. So listening to that, Z-Lab. So if you add some cluster functions, so infrastructure from Yahoo Corporation. So I think you have less dependence on the infrastructure from Yahoo Japan, listening to what you have mentioned. Right. We depend on OpenStack that was provided from Yahoo Japan in-house, but when we think of others, well, I am not directly involved with the CaaS itself, the development of CaaS itself, so I'm not sure about it, but I don't think there is much dependency on that. So at the time of delivery itself, but after the delivery, there should be some authentication. So this should be connected with in-house authentication. And for these, I think this should be, the linkage should be, alliance should be made within Yahoo Japan. But at the time of at the time of delivery, I don't think there is a strong dependency. So I was wondering whether there actually can be a miscommunication between these two companies, or as Z-Lab, you just make it a separation, so you don't want to depend on Yahoo Japan or not. Well, there is I don't know much about the history of that relationship, but probably try to avoid the dependency. That I feel that this might be a kind of trigger. I see. So when it comes to the relationship between Z-Lab and Yahoo Japan, in the Japanese market, I have an impression that it's something special. Yeah, that's true. I think it's a kind of something special when it comes to the relationships. So it was very interesting that I felt some part of your relationship. Thank you very much.